Hello! Today we will be working through a few object-oriented programming design patterns. The first of these will be the singleton pattern. The singleton pattern is a design pattern that ensures only one instance of a specific class exists while the program runs. It's basically saying only one copy of this object is allowed, no duplicates. I like to think of it like a king of a country. If you have more than one, then war would break out. It would be absolute chaos, so we only allow one person to be king in a country. Or really, one object to be of the king class for our program. Here's an example of the singleton pattern to match our king analogy. King instance is a class-level variable meant to store the only instance of the king class. So it's the royal throne, and it's empty at first because no king has been crowned yet. GetInstance is a static method, so we can call it without creating a king object first. Now, if the king instance is none, that means no king has been created yet. So it's going to create one. And now the king underscore instance is set as this created king. Then this always returns the same instance of the king, whether it was just created or already existed. So we don't get a new king each time. We're shown the current ruler and there is only one. Now, when king1 calls the get instance, that method, it sees that king instance is currently none. So no king object exists yet. So, since this is true, since king instance is none, it creates a new king and stores it in the king instance. And so this is now this king instantiation. Then it returns the king instance. And we just set that to be this king instantiation. Now, when king2 calls getInstance, the king instance is no longer none. So this statement is false. So now we just return the king instance, which is the king we already set with our king instantiation. So king1 is king2, and thus the output is true. This design pattern is really helpful for logging systems. A logging system is basically a part of your program that keeps track of what's happening, events, errors, user actions, and it does this by writing messages to a log file. Think of it like a journal your program keeps of events, and can be helpful for things like security audits. It would allow you to track access or suspicious activity on the server. Singleton is super important for this because if you don't have singleton and you create multiple logs, they might overwrite each other's logs or format messages differently. That would be like 5 different security guards writing their own journals for the day of what happened with different formatting and different things they deemed important. It would be an absolute mess. Okay then, next up is the factory pattern. The factory pattern is a creational design pattern that provides a way to create objects without specifying the exact class of the object that will be created. It's like ordering a drink from a coffee shop menu. You simply say latte or tea, and the barista handles how it's made behind the counter. You don't need to know anything about how to make it. You just say the name of the thing that you want, and you get it. Here's an example of the factory pattern to match our coffee shop analogy. First of all, we import the tools needed to create an abstract base class to define a common interface, which for this is that each drink must be able to be served. Latte is a subclass that implements the required serve method. This is your latte recipe. When someone orders a latte, the drink is served by pouring in milk and espresso and then serving it to the customer. Then, similarly, we have a tea recipe. Now we have the barista class. This is a factory class with a static method that returns the correct subclass based on a string input, which is like you saying latte or tea at the counter, and then they make it, and the barista makes it and serves it to you. So in terms of usage, you state your order. The barista, the factory, makes the beverage. Then your order is served. This design pattern is especially helpful for graphics drawing apps. In these apps, the user might select a shape like a circle, square, or triangle to draw. With the factory pattern, the menu handles the user's choice, and the factory takes care of creating the correct shape. Without it, you'd have to repeat the shape creation logic in multiple places. Okay, up next is the abstract factory pattern. This pattern provides an interface for creating families of related or dependent objects without specifying their concrete classes. So imagine that you're designing a user interface. If the user picks a Windows theme, your app needs a Windows style button and scroll bar. But if they pick a Mac theme, your app needs a Mac style button and scroll bar. An abstract factory allows you to build entire user interface kits or themes by asking one object, the factory, to give you everything in that style without knowing how it's made. So first of all, here is an example of the abstract factory pattern. So first of all, we make the abstract products. These are the base types that define what all buttons and scroll bars must implement. They are like saying every button must know how to paint itself without deciding if it's Mac or Windows. Next are the concrete products. These are the actual classes that match each theme. They fulfill the interface and do the real work. Third is the abstract factory interface, which is the blueprint for what every GUI factory must provide, a button and a scroll bar. Lastly are the concrete factories. These are the actual factories that produce the related objects for each theme. These are the Mac or user interface kits. You ask Mac Factory for a button, and it gives you a Mac one. In terms of usage, you're selecting the family of products by choosing which factory to use, and then using it to create components without directly instantiating them. This would clearly be super helpful for building a cross-platform GUI toolkit. You don't want to clutter your code with repeated if platform equals Windows checks everywhere. So instead, you use the abstract factory pattern to define platform-specific factories and let the main app simply call the factory's create methods.